had two charges, right? Two capacitors. So we had two capacitor and then they were charged. And then we joined them together. So this had C1 and C2 capacitance. And initially they had V1 and V2 voltages. But when we join them together, then their voltages become same, right? So similarly, what do we have in here? We have two spherical charges, right? And they have Q1 and Q2 prime charges, and they had some voltage, right? So when we join these two spheres together, then
Voltage
what
will be
will
equal.
happen? Yeah, then their voltage would be equal, right? So then V1 would be equal to V2, right? So
Sir,
then,
can you just scroll your screen?
yeah, so this at this point I just started.
No, sir, about that, I'll just check whether I completed it.
Yeah, so this we did in the previous class. Oh, you got disconnected, right?
No, sir, I completed, sir.
Oh, good. Okay, so this is the question that we did. So yeah, so when we joined them together, so after joining, what will happen that from higher potential to lower potential charges will flow, and then charges will acquire something, right? So this would be Q1 charge, Q2 charge, and the voltage become equal, right? So after joining them together, right? So we know that what is the potential at the surface of the sphere, right? So this would be KQ1 by R1, and this would be KQ2 by R2, right? Where K is 1 by 4 pi epsilon naught. So K will cancel, and what we are calculating? We are calculating Q2 by Q1. So this would be Q2 by Q1 would be how much? So this would be R2 by R2. So this is the first part, right? Now we want to find out that what is the electric field, right? So what is the electric field? Electric field is sigma by epsilon naught for a sphere, right? And how is that? So because electric field is kq square by right, not kq square but kq by r square, right? So this would be 1 by 4 pi epsilon naught and q by r square. So I can write it as q by epsilon naught I can take outside, and this would be 4 pi r square. So what is this is what? This is what? 4 pi r square is what for a spherical surface? Yes, guys.
Surface areas.
Surface area, right? So this is area and this is charge. So Q by A is what?
Surface charge density. Silent.
Yeah. So sigma, right? So sigma by
Signal.
epsilon. So I can write electric field as sigma by epsilon naught, right? So the ratio of from here we can say that E2 by E1. E2 by E1 would be sigma 2 epsilon naught by sigma 1 epsilon naught. So this would be epsilon naught will cancel, and this would be sigma 2 by sigma 1, right? So we have to find out what is sigma 2 by sigma 1, right?
Yes, sir.
So let us find out that, and then we can find out what is E2 by E1. So sigma 2 is Q2 by 4 pi R2 square, right? sigma 1 is Q1 by 4 pi R1 square. So we can calculate sigma 2 by sigma 1 as Q2 by 4 pi R2 square divided by Q1 divided by 4 pi R1 square. So 4 pi cancels. This R1 square goes in the numerator. So Q2 by Q1 and this is R1 square by R2 square. Right? Any doubt in this, guys?
No, sir.
So Q2 by Q1 we already know. Q2 by Q1 we have calculated and this is R2 by R1. So we put the value R2 by R1 in here and this is R1 square, R2 square. So this square will cancel. And sigma 2 by sigma 1 is R1 by R2. So you see that this is in the opposite way. Charges ratio are R2 by R1, right? They are proportional. But sigma 2 by sigma 1, they are inversely proportional, right? So we have found out what is sigma 2 by sigma 1, so we can also calculate E2 by E1, which was sigma 2 by sigma 1, which is R1 by R2. So this was the question. I guess I have given in one of the exams this question, right?
Yes, sir.
This was the
Yes,
answer.
sir.
Yeah. So please note down this problem and but some of you guys already did this problem. But let's revise it. So you guys only did this part, right? You didn't do in the question. This was not done.
Yes, sir. Only that sigma
Then
2
sigma
is.
2. Yeah. So how many chapters are coming in your exams, guys? How many chapters?
I have 10 chapters.
Uh, 7,
No, sir, 10.
10.
Yes, sir.
Holy Baba. So first to 9 are or first to 8 are from the first.
Yes, sir. Then I have a dual nature and nuclei.
Oh, dual nature and atomic and nuclei
No, sir. Dual nature and nuclei.
and nuclei chapter.
Yes, sir.
Oh, dual nature, right? And okay, so they must have just completed those chapters, right, in your school.
Yes, sir. And for alternating current, we have only have less parts. We have only the half chapter.
Oh, so half chapter of AC.
Yes, sir.
Okay, so did they omitted this transformer and LCR circuit and
I think yeah, LCR circuit is there, but I don't think so. Transformer circuit.
resonance and transformer circuit they have
Yes, sir. Resonance is there, but transformers are not.
only transformers. So one topic they
Yes,
have. So that is they are asking me 90% or 80% of it.
yes, sir.
Easy. Yeah. And what about you, Chavez? How many chapters?
7 chapters, sir.
7. Yeah. So your school is only 7 chapters, but not that is not only. But I guess this is good from 10 chapters, right? 10
Yes, sir.
chapters.
Yes.
10 chapters in one go. That is very yeah. So please prepare some. And did I send some practice questions? Important question I have sent in the group, right?
Yes, sir.
Yeah, let me check again that whether I have sent it or not. So Yeah, so I have sent in both the groups. So did you guys get the uh, what was that? Content class 12th PDF? Did you guys get that?
No, sir.
Yeah, so you guys are in which group? 12th G23 24 or which group?
So yeah, P1 batch.
And so I have this group Shahnawaz 12th G and Shahnawaz 12th B. So are you guys in that group?
No, sir, we're in Amna Maps group.
Oh, Amna Maps. So I will.
Sir, I'm not that there, sir.
Oh, you are also not there. So I will tell the Learnivio team to send you these. So did you get any practice? Did you guys get any practice type questions?
No, sir.
Sir, no, we didn't get it.
Okay, so what I will do is that can I attach this in this chat box, or let me ask the Learnivio team to send you guys. One moment, guys. So you guys can practice the question. Okay, so let's see if you get this one. But you guys practice all the others, but this could be helpful in one. So yeah, you can just look at it and then this would be easy for you.
So can you scroll down?
Yeah. Oh, where should I? Yeah, this part you guys wanted. And we have also this important derivations. Right? Okay, did you guys get any uh, PDF?
Yes, sir, we got.
Okay, so please,
Yes, sir.
yeah, Amna ma'am would have given you these. Please check that whether you got this or right. These are some questions which are important question and they can be helpful. There's another. I will find another PDF which is the list of derivations which are important. So you guys can also look at that. Is that yeah, I will try to find that one and I will send it to you guys. Okay. So first, you guys, what you do, guys, is that first prepare the derivations, and then secondly, you do all the numerical calculations. So then it would be part by part. Then
Sir, for boards you're telling.
yes,
Sir, for boards are key.
yeah, board board would be what I didn't understand.
Sir, like derivation you're telling for JEE or boards.
No, no, no. So not for JEE. In JEE, they will not ask derivations, right?
You said that only.
Yeah. So I'm just talking about those exams that are coming. So they will ask numerical. Yeah. So they will have two sections. One would be from derivations, and the other would be numerical calculations. So at least from derivations, we can get marks, right? So in numerical
So what we
calculation,
should memorize.
yeah. So
So there are more than 30 derivations right from all the chapter.
yeah. So these four chapter initial four chapters, they are the most. Yeah, so they carry the most weightage. So whenever these four are clear, then the rest ones would be easy. So we have to just these four. First four are very important. Then fifth, sixth, seventh, these are all easy ones. Okay, so whenever you guys have noted it down now, please tell me.
7 minutes done.
Done. Tarif, what about you?
Yes, sir.
Okay, so now let us do this question. We already know that whenever whenever the battery is disconnected, right, then what happens to the all the other things? Decrease or increase?
Please.
Yeah, what did Tarif, did you say increase or decrease?
The potential
Decrease.
energy decrease.
Decrease, right? So okay, decrease. And good, so you guys remember, right? So then this will decrease, right? And whenever the battery is connected, then the all the other things will increase. So this we know. Good. So keeping that in mind, right? Keeping that in mind, we have this question. So okay. So two capacitors are connected as shown in the figure with the battery and switch is connected. Then what happens that after some point, the switch is disconnected and a dielectric medium is inserted, and the dielectric constant is K inserted between the plates. Find the ratio of initial and final energy stored. So we have this capacitor, right? So this is the battery, and the capacitor is connected like and we have this switch, and firstly this is connected. So this is C, this is C, and this is V. So firstly this is the initial condition, right? And then what we do is that then this switch is disconnected. Then this switch is disconnected, and some dielectric medium is placed of dielectric constant. So this is the final condition, right? So what would be the ratio of U initial divided by U final? This is the question. Understood the problem, guys? Yes. Understood. Yes, guys, clear? Is the question clear, guys? Am I audible? Tarif and Chavez, am I audible? Hello? Are you guys there? Hello, can you hear me, Tarif and Chavez? Yes, guys, can you hear me? Yeah. Can you hear me, guys? Tarif and Chavez. Hello, Tarif and Chavez, are you guys there? Hello, guys, are you there? Hello, Tarif and Chavez, where do guys go? Am I audible? Hello? So maybe I should write it in the chat box. Everyone. Hello? Okay, so can you guys hear? Yes, everyone, are you guys there? Maybe there is some problem with my microphone or there's some problem with your microphone. Hello, guys, are you there?
Yes, sir. Here.
Oh, so where did you guys go? So did you go somewhere?
No, sir. I had some issues.
Oh, because yeah, so because I cannot hear Shave's voice and I was just talking to myself. So I wrote also in the chat box, but where is Chavez is also not replying. Chavez, are you there? Okay, so let me. Tarif, are you there?
Yes, sir. Here.
Okay, so this is the initial condition. This switch is connected, right?
Yes.
This switch is connected, and okay, so yeah. So this switch is connected, then there could be some energy stored in these two devices, right? And finally, what we do is that the switch is disconnected and some capacitor, some dielectric medium is inserted between the capacitor. So this is C, right? And this is K. So this has the dielectric constant K. So firstly, let's say this is A1, right? This is A, this is B. This is A and this is B capacitor. So what would be initially, what would be A? Let's say initial. So what would be the energy stored in A device? Yes, Tariq.
E.
Capacitance
half
is E,
CV square.
half CV square. Oh, so now you have returned. Where did
Yes,
you
half
go?
C square.
Where did you
Yes,
go,
sir.
Travis?
Yes, sir.
Okay. And what would be the energy stored in V device? Yes,
Half C square.
half CV square. Good. So this is the energy stored initially in both the devices when the switch is connected. Now we have disconnected this switch. So, but this part is connected and this part is disconnected, right? So then at UA, the energy will increase or decrease if we have inserted the dielectric medium. Remember, this is connected and this
Yes,
is disconnected.
increase.
So it will increase by k times, right?
Yes, sir.
And this is final. And in B, so in B, this would increase or decrease?
Decrease by K times.
Decrease by k times, right? So good, good. You guys remember. So this would be the final. So U initial is
Sir,
yes.
sir, how did it decrease by K time?
Okay. So we know that this is disconnected, right? So whenever this is disconnected, we have seen that in where we have seen that. Let me
Okay, sir. The first one was connected.
yeah, first one is connected, the second one, yeah, this one.
Yes, sir.
So battery is connected, then this will increase by k times, half C naught k square, right? When the battery is disconnected, then this will decrease by k times. Understood?
Yes, sir. Yes.
So yeah, we are applying the same condition in here. So okay. So this is decreased by k times. So initially the energy stored is CV square plus half CV square. So this is CV square. And finally, this is half CV square K plus half CV square by K. So half CV square is common and this is K plus 1 by K, right? So if we calculate the ratio, so this will be, let's say that value of dielectric constant is, let's say value of K is 3, right? So then this would be how much? U initial by U final. This would be CV square divided by half CV square and 3 plus 1 by 3. So this CV square will cancel, 2 will go upwards, and this is 9 plus 1 by 3. So then this 3 will go upwards, and this is 10. So this would be 3 by 5. So this is the ratio. Any doubt in this question, guys? Any doubt?
No, sir.
So please,
No, sir.
yeah, this information was crucial. That which part is correct. So you guys please note down this question.
The house A connected but not B.
So you see that switch is here, right?
Yes, sir.
This circuit is completed. This circuit is connected,
Yes.
right?
So
Switch is,
these are two different circuits.
yeah. So we have this A circuit and B circuit, right?
Yes,
Firstly,
sir.
they are connected parallelly, but whenever we disconnect this switch, so now this part is disconnected from this battery, right? But this A is already connected. So if we would, so there could be an interesting question that we have two switch. So we have two switch and then this is also disconnected, so we can have different scenario. But yeah, you can, so we can apply the switch in here also. We can, this is switch one, switch two. So if switch one is connected, switch two is disconnected, something like that. So we can have numerous combinations, and then we can find out the ratios of these energies. Yeah, but only this switch is so the switch is here. So when this is not connected, then this circuit is not connected. This circuit is not completed, but this part is already connected. So this was the idea. Okay, you guys, please note it down, and then we'll start the combination of capacitors, the combination of capacitors. Yes, whenever you guys want me to scroll down the screen, guys, please tell.
Yes, I can scroll down.
And scroll up, I didn't complete the
Oh,
question.
oh, sorry, sorry. So, is this okay, Chavez?
It's a little more.
Yes, should I scroll down, Chavez? Yes. So should I scroll it down, Chavez?
Yes,
Yes, sir.
So whenever you guys have completed noting it down, please tell.
I can just load up.
So
Yes, sir, you can scroll down.
yes, done everybody.
Yes, sir.
Done,
Shall
sir.
okay. So the next topic is combination of capacity, right? So, but before we do that, we should remember what? So, two things which are important. That in series charges are same, right? And in parallel, so and voltages are different, right? And in parallel, charges are different and voltages are same, or voltages, right? So keeping these two things in our mind, let us do this series combination of capacitor. So this you have already done, but let us revise that. So you have these capacitors, and they are connected in series. And let's say this is right. So okay, so let us. So we know that this is in series. So charges would be same, right? And voltages would be different. So V1, V2. So this is V1, V2, V3. Oh, this is 3, this is 4, this is 5. And we can add other capacitors we can add.
Sir,
So
only the charge is same.
yeah, charges are same. This is in series. This is series
Yes.
combination. So charges are same. Q, Q, Q. Right. So voltage would be total voltage would be, so this voltage which is coming in this circuit, this would be divided, right? So this would be the sum of all the individual voltages, right?
Yes,
So
sir.
what is the relation between V, C, and Q?
E is equal to Q by V.
Yeah, so C is equal to Q by V, right?
is
So
equal to Q by C.
so V equal to Q by C, right? So in this part, V1 would be Q by C1, and V2 would be Q by C2, V3 would be Q by C3, and Q by C4, Q by C5. And this is, let's say, Q by effective C or equivalence. So this Q are common, and we can take this Q as common. So this Q is common, and this is 1 by C1 plus 1 by C2 plus 1 by C3, C4, and C5. So we can cancel this one, and the C equivalent would be 1 by C1 plus 1 by C2 plus 1 by C3, C4, and C5. So in series combination, this is the effective. Uh, this is the effective capacitor. Understood, guys? So this you have already done,
So,
but yeah, just the revision of that. And when we want to calculate the internal energies, so the internal energy U1 would be how much? This would be Q square by 2C1, right? And U2 would be Q square by 2C2, and U3 would be Q square by 2C3, and so on. So this would be the internal the energy stored in these devices, right? And when we calculate the potentials, so potential V1 would be Q by C1 that we have already done. So these would be the case, right? So this is about series combination. And what happens with the parallel combination? So in parallel combination, so we have this voltage, right? And these are the capacitors that we are connected, right? Let's say we add three capacitors. So this is C1, C2, C3, and this is B. So as because this is a parallel combination, so we would be safe, right, guys?
Yes.
So V is same, which means that charges would be different because there is the branching of the charges. So whenever there is a branching of charges, so the charges would be different. So the total charge would be Q1 plus Q2 plus Q3, right? So this is this Q. We know that this is CV. So we can write this as C equivalent V, and this would be C1V plus C2V plus C3. So again, we can take a V common. So this is C1 plus C2 plus C3. And this is C equivalent V. So V cancel. And C equivalent is C1 plus C2 plus C3. Right. Similarly, we already know that what is Q1. So Q1 is C1V, Q2 is C2V, Q3 is C3. And we can also calculate the energy stored. So this would be half C1V squared, and U2 would be half C2V squared, and U3 is half C3V squared. So in this way, we can calculate. Right? This you guys already knew, right?
Yes.
So we have to remember that in parallel combination, this is the scenario, and series combination, there is the other scenario. So please, you guys note down this part. I know that you have already done the CBSE course, but please note it down. So if we repeat things, then it becomes, then we can remember it for a longer time. Whenever you guys want me to scroll down the screen, guys, please tell. Madiha is not here.
So can you scroll down?
Faiza is also not here. Many people are not here. So we can add all other capacitance, right? But I took five, so I should have taken three ones. So yeah, you can add more capacitors on. Yes, whenever you guys have noted it down, step. Yes, whenever you guys have completed, please tell me. that I can scroll it down. Yes, noted, guys.
So
Tariq
can
and
you scroll down?
noted, everyone.
Doing this one, sir.
So whenever you guys have completed a step, yes, whenever you guys have noted it down,
Yes, certain.
okay. Shavez, what about you? Yes, Shavez. Yes. Uh, okay, so now let us do some questions. So remember how do we recognize that what is parallel combination, what is series combination? So you see that this is positive, this is negative. This is positive, this is negative, this is positive, this is negative, and this is positive, and this is negative. So when all these positive ones are connected together, then that is a parallel combination, right? So we connect all the positive terminals in one side, we connect all the negative terminals in one side. So that is the parallel combination. But when we add the alternate terminals, right? So we connect the negative ones with the positive ones. So then that kind of combination is series combination, right? So we connect negative one with the positive one, negative one with the positive one. So these kind of connections are called series combination. So keeping that in mind, let us do some questions. So we have these two rods, right? And they are placed. These are two rods, and this one is connected to the positive terminal, right? And then we have this negative terminal, right? So then this is connected to this one. This is connected to negative one, right? So this will acquire a positive charge, right? This will acquire positive charge. This will acquire negative charge, and this will acquire negative charge. Okay, so these distances are same, right? This is so my figure is wrong. So let me. Okay, but I will write no write off the distance. This is D. This is also D. This is not looking like D, but this is also D. And this is also D. Okay. So can you tell me how many capacitors are there? Uh, Chavez, are you around? I guess Chavez is not here. So Tarif, can you tell me how many capacitors are there? How many these combinations do we have? Positive ones and negative ones. How many combinations do we have? Yes. Did you identify? Tarif. Yes, Tarif, are you there? Yes, Tarif, are you there? Can you hear me, Tarif? Hello, Tarif, can you hear me? Tarif and Chavez. So you guys go on a break again. Hello? Yes. Can you guys hear me? Is my mic working? So, hello, guys. Hello. Hello, guys. Can you hear me? Yes.
Oh, yes, I can hear.
Oh, so yeah, did you go somewhere again?
Yes, I still had to get out.
Oh, okay. So please tell me when you guys
Oh,
go
I'm sorry,
because
Seta Sergeant.
yeah, because Chavez is also not here and I was talking to myself. So Yeah, so we have this question. We have these two rods, right? They are connected to positive terminal, and these two rods they are connected to negative terminal, right? So and this
Yes.
and yeah, so then this has a area, right?
So D is the distance of the.
Yeah. So this is not looking like the same distance, but I have messed with the images. So I have messed up with the figure, but this should be the same. So the figure is like this. So like this. Then this is connected to the positive one, and this is connected to the negative one. So now you see that this distance is same, this distance is same, and this distance is same. Understood that this is this figure. Is this clear? So let me draw this figure clear. So let me draw this. I have the rods, and this one is connected to the positive one. Okay, and this one is connected to negative. This is negative, this is positive, right? So this would be what? This would be positive, and this would be negative. This would be positive, and this would be negative, right? So the distance between them is d, and the area of all these plates are a, right? They have the same areas. So can you find out how many capacitors are there, Tarif? How many capacitors? How many this kind of combination do you have? Yes, Tarif, are you there?
Yes, I mean.
Yeah, so Chavez is not there, but okay. So how many capacitors that you can find out? How many this kind of combination are there?
So it's parallel and series.
Yeah, so parallel and series. We'll figure out what are the parallel ones. But first,
So parallel will be D2 and D3, right? And D1 is series.
so okay, we will find out that whether these are parallels or in series. But first, you tell me that yeah. First, you tell me that how many capacitors do we have in this figure?
3.
Three, right? So we have this first combination, which is positive and negative. So this is one, right? Positive one and negative one. Then we have this negative and positive, so two. And then we have this positive and negative. So we have three capacitors. But you see that all the positive ones are connected to one terminal. All the negative ones are connected to the other terminal. So this is a parallel combination or a series combination.
Parallel.
Parallel, right? So all these, so the effective diagram of this one is, so this is the effective diagram. So I'm drawing the parallel. This is, and then this is connected to this. So you see, this positive one is connected, this positive one is connected, this positive one is connected. So this positive one is connected, this positive one is connected, and this positive one is connected. Can we have the class from 6 to 7:30?
Sala
Okay.
went to Salas.
Oh, you went to Stella. So, okay. So, did you see this question?
No, sir.
Okay, so we will discuss this question in the next class, right? We will stop it here and we will discuss this question. So, up to this point, you noted, right, Shaved? Yes.
Yes, yes.
So, I will